Hello everyone, my name is Amparo López and I am full professor at Universitat Politécnica de Valencia in the Department of Environmental Engineering and Hydraulic Engineering. Today we will be speaking about the control of the operating point of a hydraulic pump by valves in the facilities. So when we finish, we will be able to understand the need of regulation in the system to several water distribution networks and to recognize the different ways in which we can regulate the operating point of a particular pump with valves in series or in parallel. So what we will be speaking about the need of regulation in the pumps, about the regulation over the set point curve with series valves and with parallel valves to finally conclude. So why do we need to regulate the systems to control? Because once we use a pump to provide a particular pressure and flow, what we do is to make an intersection in between the flow and head curves of the facility in yellow color and of the pump in red color. In this case, the achievement of the Bernoulli's law makes us to have a flow and a head while intersecting both curves. So if we need to control flow and head in the system, we will have to operate over one of these curves. In this case, we will be speaking about operating about the set point curve, about the resistance curve, in which we will be changing the operating flow and operating head by changing this yellow line representing the facility. So how can we do this? We can do this by changing the facility, by changing the pipes, by changing the heads, and so. But this is not easy to do in a real system because we have to change completely the network. So easier to do is to implement valves across the system. Related to the pump position, we can implement the valve in series after the pump. In this case, we will increase the pressure needed for the system to give a particular flow. In this case, when we consider the performance of regulation relating the minimum power in the system with the total absorbed pumps in the pumps, we will see that to provide the flow, we increase the head because we are changing the set point curves. So the performance of regulation is the relationship in between heads in this case, which is smaller than 10%, 100%. In the second case, if we work with parallel valves, what we are doing is to put a valve in parallel with the pump to recirculate the flow by diversion in a bypass installation. In this case, when we see what happens is that we're giving more flow than needed for the system in order to recirculate to have the achieved head that we need. In this case, the performance of regulation is the relationship in between the flows for the desired point and the pump point. And in this case, again, this performance is smaller than 100%, smaller than maximum performance of the system. So we can choose by putting the pumps and the valves in series or in parallel to control head or to control flow to give exactly the set point that we need. But in any case, we will be losing some energy because we give energy extra for higher head or higher flow that we are not needing in the facility, but it is required for regulation. So we can conclude that regulation is necessary to provide exactly points conditions required by facilities, and these pressures and flow conditions can be achieved either by acting on the characteristic curve or on the resistance curve across the set points. In this case, we consider the resistance curve and we analyze how we can introduce parallel valves or series valves to have these points, in any case with less than 100% of regulation efficiency, but needed in any case to provide exactly the point that the facility needs. I hope this was of interest. Thank you very much indeed.